So we are going to use this Laplace transform to solve or to analyze the electric circuit. So in order to do that, we need first to convert all elements or all components in the circuit from the time domain to frequency domain according to the table that we shared before. Then also the either the components like resistor, capacitor, inductor, or also the voltage or current source. Then we are going to use algebra to set up or solve the circuit equations. So if you have, for example, one loop, so you are going to write one equation and solve it. If you have two loops, you are going to write two equations and solve. If you have three loops, you are going to write three equations. If you have two nodes, you are going to write also two equations and so on and so on. So the same way that we follow when we analyze the electric circuit in the time domain, we are going to apply in the frequency domain, but it become more after we convert all elements into the S domain. So all the theorems and relationship developed for the DC work in the I mean the DC network or the AC network will be applied here. So this is the first example, and in this question we need to find the value of V out or V out of T by using a Laplace transform. So you need to firstly you need to convert or redraw this circuit from the time domain to the frequency domain, and he already gave you here assume initial conditions. So you are not going to consider this initial condition that we talked before when we calculate the circuit. That means this will be ignored. This part will be ignored for the capacitor part, and also for the inductor part. This part will be ignored. So we only consider the values, either the value of the element and the value of the voltage and current in our circuit. So when said the initial condition are zero, that means all I0 equal to zero and all V0 will equal to zero. So not consider. The next step you need to do is to convert or transform this circuit from the time domain to frequency domain. How we can do that? We need to apply the formula that we have for the elements inside the circuit and redraw the circuit with the new values. So this is make it easier for you in order to solve the or to analyze the circuit. So you have this is capacitor, for example. You redraw the circuit as it is, but you are going to highlight what are the values for the voltage, for the current, for the capacitor, for the inductor, and for the resistor in the time domain. I mean in the frequency domain instead of time domain that is given in the original circuit. So this will be the value that you need to find. So V out here, all the elements in the circuit should be in the S domain. So any small letter will be converted into capital letter, and any T will convert to S. So for example, this become like V out of S. This L here, you have one L or 1 Henry here. We said the value of L in the time domain, I mean in the frequency domain, will be SL. So you need to multiply the value of L times S. So the value of L is equal to 1. So times S will equal to S. So this is S here. Then this function of the current here, the value of the current in this current source is equal to 2 UT. Okay, so the 2 UT here will be, I mean this 2 UT ampere. Okay, this is because it's voltage source. So the value of the 2 UT here is equal to, when you convert this one from the time domain to the frequency domain, it will give you this value, which is 2 over S. This is from the table that you have, because we have step function. For step function from time domain to find Laplace for this one, it's give you 1 over S times 2, so it's become 2 over S. So this become 2 over S, and 1 over 4 farad will be converted according to the formula 1 over CS. So what is C here? C is equal to 1 over 4, so it's become like 1 over 4 S. So this 4 will go up to the numerator, so become 4 over S. Okay, so this is the value will be 4 over S. So you are going to substitute again here 4 over S. So this is the new circuit that you have in the frequency domain, and the value of the or the direction of the current, for example, in this circuit will be like this one, and it will divide it into two parts. One part go to the voltage, one part go to the capacitor. I mean, one part will go to the inductor and resistor here, and one will go to the capacitor. Now you are free to use any method that you learn. Either you want to use the voltage divider, you want to use the current divider, you want to use mesh analysis, you want to use current analysis, nodal analysis, whatever is the method that you feel is easy for you and you feel confident that you can get the correct answer, you can apply to find the value of V out S. Your task will be to find V out S. So we are going to write equations in order to find the value of V out S. And here we will apply just the KVL or I mean Kirchhoff voltage law or Kirchhoff current law inside these two loops in order to find the value of the V out S. After you get the value of V out S, this is the voltage in the frequency domain. You are required to solve it or find the inverse Laplace transform. So you are going to solve for V out of T. So you are going to find V out of T, and this is the missing value in our equation. Okay. So how to write this equation for this, how to solve this, this circuit, or how to analyze? We can write the equation here based on the value of the current that we have. So this current will be divided into current, we call it ILR, which is the current which go through the inductor and the current which go through the resistor at the same time. And also here we have the current, we call it IC. So this is the current will go through the capacitor. So the voltage of the capacitor in this case will be the current times the value of inductor. I mean the value of the impedance here. So the current, I mean the voltage of this capacitor will equal to IC times 4 over S. So the voltage across this capacitor is equivalent to the voltage across these two elements, which is the inductor and resistor. Because if you apply KVL here, you said VC, for example, this is VC, we call it VC, or voltage across the capacitor, plus VL plus VR or V out is equal to 0, because the summation of all voltage in this loop clockwise will equal to 0. So VC plus VL plus V out is equal to 0. Or you need to consider also the polarity or the direction, because if it is like this one, so this will be negative, go to the other side. If this one is positive, negative, so the arrow here direction will be on that side. So you need to revise or to go through again for this, how to apply the KVL and KCL in the circuit analysis. So we can write the formula here or the equations for our circuit. As you can see here, VC is equal to VLR, because we have the VLR here represent the voltage across VL across the inductor plus the voltage across the resistor or the V out here. We call it the V out. So if you substitute for the value of VC here, value of VC when you have the voltage, I mean you have the current and you have the impedance, which is 4 over S, and you have the current, we call it IC. So IC times 4 over S will give you the value of the capacitor. This is on the left side. On the right side, you have the current which go through both elements, which is inductor and capacitor. This inductor and this capacitor are two impedance in series. So if you want the total impedance here, it will be S plus the value of R, which is equal to 4. So it was S plus 4. So the total impedance is plus 4, and the current or the total current here, we call it ILR. So the voltage on this part, which will be ILR times S plus 4. You just substitute for this value. So IC 4 over C on the left side. Here you have ILR times S plus 4. You can see how we add using algebra directly. You have this is impedance, this is impedance. This impedance value is S, this impedance value is 4. Just substitute for the value. Then we try to solve for IC. So IC here, that means you are going to multiply this part by S. This part will be 4 here. So it's become like S times S, S squared, S times 4, you have 4S, and you have 4 here in the denominator, and you have the value of IL. Now, the voltage source current, which is IS, is equal to the summation of IC plus ILR. So here, as you can see, this we have the voltage source, and this voltage source is equal to 2 over S. So this one is 2 over S is the current of the voltage, the current source. So this current source will go to this point. At the node here, it will distribute into the two directions. So the sum 2 over S or IS here will equal to ILR plus IC. Just substitute for the value here. So IS equal to IC plus ILR. IS is equal to 2 over S. This given the value of the current source. IC is here already, which equal to IS squared plus 4S over 4 ILR. So you just substitute here for IC this value. Then plus ILR and the ILR value here. Now we need to solve our equation for the missing variable, which is ILR, to know what is the current which pass through this inductor and also resistor at the same time, because they are connected in series. Because why I need to find ILR? If I find ILR, I multiply by 4 by R here or by the resistor, I can find the value of V. Because according to Ohm's law, V equal to I times Z, correct? So I have ILR here, and the Z here represent 4 ohm only. I just substitute. So after I solve this equation, but for ILR, I find ILR equal to 8 over S plus or times S plus 2 all square. I multiply by 4. This is the value of the resistor, which is ohm. So I can find the value of V out. So now we can calculate the value of V out in the S domain, which is V out of S equal to 32 over S plus 2 all square. So this is the value of V out, but not the value that we want. The value that he asked to or want to know is the value of the voltage in the time domain. So our task now to solve this equation or to apply Laplace inverse for this equation in order to find the value of V out of T. Because this is V out of S, if I apply Laplace inverse, this one is Laplace inverse, I can got V out of T is equal to a value here. So this value is the required value in my question or in my example here. So how we can find the inverse Laplace for this equation? We need to apply this equation. Actually consists from 3 poles, and 2 poles are repeated. So you have S plus 2, that means it is S plus 2 times S plus 2, and we have S here. So you have 3 poles, but 2 of them are repeated. So you are going to apply the method of inverse Laplace that we learned previously in order to find the value of, or the inverse partial fraction method here, to find the value of V out as a part. Then this part will be find there. We are going to find their Laplace inverse in the table of the Laplace transform. So this is using partial fraction. You just apply partial fraction as usually before we learn. So A over S, B over S plus 2, C over S plus 2 squared. We are going to calculate the value of A, B, C. So A is 8, B is equal to -8, C equal to -16. So we got this formula or this value for output voltage. And this value of output voltage actually is easy to be convert into the time domain from the table. So you have 8 over S. You just go to the table, you find it is 8 UT. You have 8 over S plus 2. You find it from the table, it is 8 exponent -2t. 16 over S plus 2. So this is 16t exponent -2t. So this is the value of UT, or the value of the output voltage that is required from our circuit. I'm sorry. So I mean, from this, by using Laplace, we can find the value of the voltage on this circuit. If I ask you now, can you try to find the or to solve this or to analyze this circuit in the time domain, and you see how which one is easier? Either you use directly the time domain here, or you go for using Laplace transform. So it's not easy to find it by using the time domain. It's not like value that you have, because you have a function here. It's not just direct value. It's not just 5 volt, 10 ampere, and so on. It's just because you have here some of the variables, and you have elements which involved in your calculation to analyze this circuit.